Okay. We have to identify what 3 is. What is 3 for number 2? 3 is what? Dilation. So, we write 3 as dilation. Next. What about 3 minus x? Now, I'd like you to look at right here. I'll just write here the 3 minus x. 3 minus x. Now, the normal thing that we do is like this, x minus 3 or x plus 3 or whatever. But in this case, can we switch this into writing negative x plus 3? Yes or no? Can we switch it this way? But we wanted the x to be positive. Therefore, we are factoring out negative. So if we factor out negative, this means x minus 3. You get me, guys? Now, what is this negative 3? If on the negative sign right here, if 3 is dilation, what is this negative? And it has something to do also with number 3. The negative is right here. Okay? But since if we rewrite Marina, if we factor out this negative, now turns into horizontal reflection. Again, what do negative implies right here? This is horizontal reflection. But for number 3, where do the negative is situated? A negative is before the logarithm. This negative right here in number 3 is the vertical reflection. Do you hear me, guys? This negative right here written before the logarithm is vertical reflection. But if I'm gonna rewrite number 2, we have h of x is equal to 3 log of base 5, and then we have negative, and then x minus 3 plus 1. The minus is right here. So this is horizontal reflection. Okay? While this one is vertical reflection. Do you get me, guys? So let us identify now where it is shifted, to the left or to the right. This is now our new, that is now how we rewrite. So that means, where is the shift, left or right? Right of 3, right? So right 3. And how about this one? Is it up or down? The plus 1. It's gonna be up by 1. So up 1. Okay. Any question on this one? why it is right, because we want to express as x plus or minus whatever is the number. Okay, so moving on to number 3, but please, I'd like you to graph number 2 now, and then copy that graph in your workbook. So, moving on to number 3. What is that number 3? What is this negative? This negative right here refers to vertical reflection. So, it's going to be vertical reflection. Are you going home? Okay. Hope you feel better, okay? So you don't practice this afternoon. Okay. Take care, Ricky. So once it is negative, it is vertical reflection. Now look, a while ago, for number 2, we rewrite this one and then we factor out the negative. If the negative is right here after the logarithm, it is horizontal reflection. But if the negative is written before the logarithm, it is vertical reflection. Okay? So that's how we distinguish vertical reflection and horizontal reflection. Okay, Ale. Vanessa, Edward, two of you. So, where is the shift right here, guys? Left or right? Right, this one. Left. For this one, where is the shift? Left or right? Is it towards the left or to the right? This is negative, so therefore this goes to the right. Right 3. And then what's next? What is negative 2? Up or down? Down by 2. Right? So down 2. So, again, I need you to label each graph right here. So I need to see 3 graphs on your workbook. Can I move this up now? Okay, for number 4, 5, 6, 7, it says find all relevant information from the given function. Sketch a graph, and we don't have to do calculator. All you have to do is just sketch the graph. Okay. From this one, natural logarithm of x minus 3 plus 5, that means the shift is to the left or right? To the right, right? So right. So if we graph this one, it's gonna be 3 units to the right. Okay? 3 units to the right. So 1, 2, 3. This serves as your asymptote, vertical asymptote. So the vertical asymptote is what number that this gives us 0. What value of x that this inside gives us 0. It's gonna be what number? 3. Okay, that means our vertical asymptote is at x is equal to 3. So this is now our vertical asymptote right here. Okay, so and next we're gonna do, that means the number is going to the, because this is shifted to the right, right? The shift is to the right. That means starting here as our vertical asymptote, our graph is right here. Okay, now this is plus 5, which means the parent graph is being pushed how many units up? It's gonna be pushed 5 units up. Let us have the domain, the value of x, the domain from vertical asymptote. Where do you think is the domain goes? It goes right here, starting 3 all the way to positive infinity. Did you get me? That's the domain, the value of x. So basically the graph looks like this. This means as the value of x goes to infinity, the range is also coming here, or going to infinity, and also the negative infinity. That's the range. But the domain starts at 3 all the way to positive infinity. You get me, guys? So therefore the range, the value of y is coming from negative infinity all the way to positive infinity. So from negative infinity to positive infinity. Say end behavior. The end behavior. When we say end behavior, it is the value of x, left and right. For end behavior, let's take a look on the left value. So x left of 3. Left of 3, meaning we are considering the domain left of 3, which are these numbers right here. Okay, left of 3 are the numbers negative, 2, 1, 0, negative, and so on. Okay, that means the function f of x is what? It's gonna be negative infinity. However, if we do positive values of x, as x goes to positive infinity, as x goes to positive infinity, what happens to y? What happens to y? The y is going up. Okay? If we take the value infinity, as x goes to 1 million, what happens to the function? The function goes up. So which means f of x is positive infinity. Okay, is number 1 clear? Now, before we do number 5, I want you to graph this number 5 first in Desmos. Can you graph number 5 now? Negative 2 log of x plus 3 base 2 minus 6. Okay, let's sketch the graph first. X plus 3. Where do the shift goes? Where do the vertical asymptote goes? To the left. Very good. So, we have x equals negative 3. So, this is the vertical asymptote. That means we expect that the graph lies right here on the right side. Okay? So, negative 6. So, shifted negative 6. So, left 3 and then down 6. And then, since this is what? Is this dilation or vertical asymptote? I mean, that's vertical, right? Because it's negative. Once it is positive, it is dilation. But once it is negative, it's gonna be vertical. Reflection. It's gonna be a reflection. Vertical. So the graph goes this way. Is your graph similar to mine? Okay, so this goes up and this goes to infinity also. So let's have asymptote. What is our asymptote? X is equal to, where is the asymptote? Negative 3. And let's have the domain. Where do the domain starts? From here. From negative infinity, I mean negative 3 all the way to where? Positive infinity. So the domain is negative 3 to positive infinity. Okay. What about the range? Let's take a look at the bottom. Is this going down? Yes or no? So from negative infinity. And then how about on top? Positive infinity. So negative infinity to positive infinity. Now, what about the end behavior? The end behavior, we're gonna consider first the left of negative 3. What are the left of negative 3? Negative 4, negative 5, negative 6, negative 7. So, all numbers going to the left. So, for end behavior, we say for x, negative 3, left of negative 3. So, what happens to the function? As the value goes to the negative infinity, as x goes to the negative infinity, what is y? Y is going up or down? Going up. So that means f of x is approaching positive infinity. Okay? And then, how about the right of negative 3? As x approaching on the right of negative 3, the function is going where? Where do you think the function is going? On the right of... I need you to react. I said left of 3. Left of 3. Where do you think is the function? The function is on the negative infinity. And on the right of 3, where do you think the function for n behavior? It goes positive infinity. Okay? You went to the college center? And I move this up now. We do number 6. Okay, what do you think is the asymptote? Left or right? So that means x equals 8. Asymptote x is equal to 8. So once it is written this way, what we do? Rewrite, okay? Why? We need to have a reflection. This has a reflection from 8 minus x. We can rewrite this into negative x plus 8. Alright guys? But we want x to be positive. So we factor out x negative, and then this must be minus 8. Okay? So the shift is left or right? It's gonna be right. That's the shift. How many units? 8 units. So if we have the graph, if we graph this one, it's gonna be right here at 8. Okay? At 8. And then you have vertical asymptote. Is that clear, guys? So the asymptote x is equal to 8. And then where do you think are the values of x coming? The graph. The graph is coming from here. So which means the domain is coming from negative infinity all the way to 8. Okay? Negative infinity to 8. And how about the range? From negative infinity to positive infinity. Okay, let's have the domain. What are the numbers left of 8? 7, 6, 5, 4, 3, 2, 1. So we say x, we have left of 8. Left of 8, f of x is negative infinity. Okay? And then how about the right of 8? It's gonna be positive infinity. Okay? Again, the graph looks this way. Can you graph in Desmos whether it is similar to this one? Okay, so it's gonna be as x on the left of 8, it's gonna be down, right? Okay, and next, how about on the right of 8? or as x is going to positive, so f of x goes where? Where do you think is the function?
Positive infinity.
We are on n behavior.
Positive.
It's gonna be positive infinity. Okay. Is the graph looks this way? Who graphed this one, guys? Is it similar to this way? Okay. So moving on to number 7. What is this? Negative. What is negative? It's gonna be a reflection, vertical reflection. So can you write that down? That negative is a vertical reflection. And how about the asymptote? What is our asymptote? X is equal to 5 halves, 5 over 2. Okay, so 5 halves, or in decimal form, this is 2.5. Okay, why 5 halves, Mr. Roy? Remember, you're gonna have 2x minus 5 to be equated to 0, so 2x is equal to positive 5, so x therefore is 5 halves. Okay. Okay. So, what is the asymptote now? The asymptote is 5 halves or 2.5. How about the domain? If you graph this one, if we sketch, this is 2.5. Okay? So this is the vertical asymptote. And where do the graph goes? If you graph this one, the graph looks like this. Okay? So we have domain. What is the domain of this? The value of x. So domain 2.5. Since 2.5 is vertical asymptote, then the graph goes right here. So it goes to positive infinity. How about the range? From bottom to top, we have negative infinity all the way to positive infinity. How about the end behavior? As x goes to infinity, as x goes to positive infinity, and as x goes to the negative infinity. What is that? End behavior. Right of 2.5. So the right of 2.5. And then that means it's gonna be positive infinity, right? Domain, values of x. So f of x is positive infinity. Or instead of putting equals, so approaching positive infinity. What else? As x goes to positive infinity, as x goes to positive infinity, the function itself is, as this goes to positive infinity, where do you think is the behavior of the graph? Is it positive infinity or negative infinity? It's gonna be negative, okay? So, approaching negative infinity. And I move this up now. So we'll do number 8 and 9. So we stop until 8 and 9. And then we're gonna continue the discussions tomorrow. We have like 10 minutes left, right?
Yeah.
Okay. So what is 455, guys? What you know about 455? It is what? Vertical, horizontal? It's gonna be vertical, right? Sure? Hmm? Okay. So, let's take a look on x plus 376. What is our asymptote? Asymptote x is equal to 376. Okay, 376. If we sketch the graph, so from here, let's say 376. So, this is our vertical asymptote, right?
Mr. Roy, isn't it negative 376? Yeah.
Thank you. Someone reacted. I have the intention why I wrote it this way. Why? It must be negative. Okay? So it must be negative. So, our vertical asymptote is negative 376. Okay. So, what about domain? So, domain, values of x. Since this is vertical asymptote, so it is restricted right here. Negative 376 all the way to positive infinity. That's our domain. Okay? How about the range, guys? Could anyone sketch this in the graph? Desmos. Sketch the graph.
Me?
Your graph looks this way. Is my graph similar to your Desmos graph? More or less similar. So, what about the range, guys? Look at the value of y. Starting right here at the bottom, negative infinity, all the way to the top, positive infinity. So the range is negative infinity all the way to positive infinity. And then end behavior. As x goes to positive infinity for end behavior. As x goes to positive infinity, what is the function? As x value goes to positive infinity, where do the graph goes? goes up. So it's going to positive infinity. So f of x approaching positive infinity. And if we do the right, of negative infinity as x approaching the right of negative infinity, to the right of negative infinity, then, or to the right of negative 376, then the function goes where? Goes to the negative infinity. So moving on to number 9. What is the asymptote? What is the asymptote? X equals 10. Okay? So can you continue doing the domain, range, and behavior and sketch the graph? Who has the domain now? From negative infinity, because if we sketch this one, the sketch would be right here at 10, right? So it's coming from negative infinity. Domain from negative infinity up to 10. So negative infinity up to 10. How about the range? Still from negative infinity all the way to positive infinity. How about its end behavior? Can you sketch this graph? What if the graph looks like? Looks like this way. So can you write the end behavior? As the value of x goes to positive, the right of 10. So as x is on the right of 10, the function is going where? Approaching negative infinity. Okay? And if the value of x goes to the negative infinity, as x towards the negative infinity, the function is approaching where? Going up, right? It's gonna be on positive infinity. So we're gonna continue the discussions tomorrow.